Thank you very much. Thank you. And good morning, everyone. Thanks for joining me, and pleasure being here at Kubernetes Community Days Czech and Slovak. Back again, actually. Last year I had the privilege of being on stage in Prague and seeing quite a few of you. So now getting to see the other half here in Bratislava, the Slovak half, and meeting the CNCF community here. And this time I would like to talk to you about the OpenSearch open source project. But just to get to know you, who, with a show of hands, who knows the OpenSearch project? Okay, I see one guy here that I know for sure. And who uses OpenSearch? With a show of hands. Okay, splendid. Happy to talk to you about it afterwards and hear your experiences. For those who don't know OpenSearch, who knows Lucene or Lucene-based systems like Elasticsearch, Solar, and others? Oh, okay, brilliant. So getting the sense of the audience here. A word about myself. My name is Dotan Horovits. And what you can see here on the screen, this post is actually from last month from the OpenSearchCon Europe. That's our regional yearly conference. This year it was held in Amsterdam. Actually, this week we have OpenSearchCon India, and in a few months in North America. Really exciting. So I'm the Chief Evangelist for the OpenSearch project. I also work for AWS as a Senior Developer Advocate for the AWS open source team, primarily focused on OpenSearch and open source observability. Happy to talk about these topics afterwards as well. Besides my AWS day job, I'm also a CNCF ambassador. A pleasure hearing Zdenek just before me talking about the Cloud Native Computing Foundation and showing you all the stats. So he spared me all the intro there. CNCF ambassador. And I also run a podcast called Open Observability Talks. So if you are interested in these topics of open source, DevOps, observability, and the likes, do check it out on your favorite podcast app. And as you can see, you can find me everywhere at Horovits. So happy to chat with you also after the conference. Just feel free to reach out. Happy to talk. And for those who don't know OpenSearch, I've seen quite a few hands there. So let's recap about the project. OpenSearch started back in 2021, 4 years ago already, as a fork of Elasticsearch. Elasticsearch and other components of the Elk stack after they have been relicensed off of open source and into a non-open source license, SSPL. And of course, the community users understandably still wanted an open source alternative for search, analytics, log analytics, observability, and AWS stepped up and initiated this fork. So that was 4 years ago, and I'm really excited to share with you that the project has moved a long way in these 4 years. As you can see the stats, we've now had over 1 billion downloads of the project to date. We've had 25 releases across 133 repos on GitHub. And all of that is thanks to the amazing community behind it. You see some of the stats over here. 3,600 members on our public Slack channel, and 6,800 on the forums. And most importantly, over 1,000 contributors from across more than 30 different organizations. So really exciting. And yeah, talking about the result, today it's now the 4th ranked search engine in DB Engines. That's a new screenshot that I took just recently, but it's been consistently that for quite some time. So really the project has come a long way in these 4 years. Now, Zdenek talked about open source, so the biggest news on the open source front of the project came from back in September from Vienna, from Open Source Summit, where we announced that the OpenSearch project became part of the Linux Foundation. So it's now a top-level project under the CNCF. We also established the OpenSearch Software Foundation as a non-profit organization to foster open governance, open collaboration. So it's now an independent, vendor-neutral project. We have our governing board. We have technical steering committee with representatives from different companies and stakeholders. And organizations like Uber, SAP, NetApp, and many others, you see the logos here, that have already joined and are now helping to steward the future of the OpenSearch project. So I hope that I convinced you that this is an interesting project, that this is an open source project, a foundation-led one, and interesting to explore. And now let's talk about what OpenSearch stack is about. So the main component is, of course, OpenSearch Core. That's the distributed search engine built on Apache Lucene with document storage and indexing capabilities, and with built-in vector database. And I'll talk about it soon. So essentially, you take documents, think about JSONs, potentially containing unstructured data, plain text, and then, of course, it could be other types of data like geospatial coordinates and so on. And then you store it, and then you can query the data over a very simple API. For those who know Lucene-based systems, pretty much what you already know. So that's the core. Then we have the OpenSearch dashboards. That's the front-end UI visualization toolset where you can query the data not via API but on UI. You can create your dashboards. You can create visualizations. You can create alerting, team collaboration, workspaces, data management, and so on. And the last major component is the data prepper. That's a lightweight data collector for enriching, transforming, and aggregating the data. So these are the main components. Of course, there are also client libraries and integrations. I'll touch upon them later on. And of course, don't worry, you can run it on Kubernetes. I know we're here in a cloud-native audience, so it supports Helm charts that will help you deploy the application in a vendor-controlled, reproducible manner. So don't worry about that. So let's talk about how people actually use OpenSearch. There are many use cases out there, but they largely fall into these 4 buckets. First is search. OpenSearch is at its core a search engine providing highly scalable and performance search functionality that people use like enterprise search catalogs, e-commerce websites, and so on. It's also widely used for log analytics and observability use cases. And as we're here in a Kubernetes and cloud-native audience, I'll definitely delve into these soon. We also see growing use of OpenSearch as a backend for AI and machine learning powered application, with a powerful vector database that it has, with integration with AI frameworks such as LangChain, Llama Index, and also native ML composable workflows, and also out-of-the-box security analytics to help you detect, investigate, and respond to threats in real time. So these are the use cases. I won't be able to cover all of them, but I'll focus at least on the first ones. And let's start with search, which is, as I said, the core of the project. And we have a gentleman that asked if I'm only going to talk about observability, so I promised him to also talk about search. Search engines, in general, what they do is match terms to objects in a catalog. Like in this example that you can see here on the screen, essentially you have, oh, sorry, that's going to be challenging. Yeah, so, very good. Here, you see essentially writing convertible olive couch, and you get the results. You get the results that match based on lexical matching, keyword matching. Also, you get the results automatically ranked or sorted by their relevance. So search engines have built-in algorithms to rank the relevance of the results, how closely they match, similarity, and then you get the results automatically sorted by their relevance. There's also an aspect of facets. Let me move to this one so I can show you. So facets is what you see here. These are the checkboxes that you see usually in these websites on the left-hand side. And then you say, okay, you want to drill down into search results, show me only a couch of this material, of this color, or this color, brand, style, and immediately it narrows down based on these attributes. So these are facets in a nutshell. There's also support for geospatial search. So if your documents contain geospatial coordinates, you can also search results that fall into a defined bounding box or shape or something like that. There's also support for fuzzy matching. So let's say one letter is missing or one letter is misspelled. You still want to see relevant results. This is fuzzy matching. And as I mentioned, vector search. So this in this case, your unstructured data is represented as vector embeddings in a multi-dimensional space, and then it enables vector similarity search or proximity search. So that's search, and I want to show you a short demo for that. So let's have a quick look here. Switch over to my demo. Here we go. Okay. So you can see my window, and this is the example of an e-commerce monitoring, e-commerce dashboard essentially, and you'll see what you'd expect to see: sold products per day, sales by breakdown by gender, how many female, male, average sales price, average sold quantity, total revenues. We also see the trends over time. We see the breakdown, how many women's clothing, men's shoes, and so on. You see the breakdown here. And the trend, we see promotion tracking, so you see the trend over time. Then you see these vertical lines that show when the promotion occurred, and then you see how it affected the sales. You see the map, interactive map that shows where around the world the shoppers came from online, top-selling products here. Pretty much, and this is of course a dashboard that you can design yourself. I want to also show you this, because this is essentially the raw data. We talked about these storing documents. For those who don't know what I mean, if I look at the JSON format, so you get a JSON that has all the data that you'd expect. You have the currency, the customer first name, gender, last name, phone number, and so on. You have the product details like the category, the discount amount, and so on. Price, and so on. This is what I meant by document, and this document is then indexed and stored within the OpenSearch core, essentially, and then you get all of that nicely allocated, each one with its own type, and you can query on that data, you can filter on that data. I can go here and I can say, okay, I want to see only, let's say, day of week. Only day of week is, let's say, and I don't need to remember even the values, it will fetch them automatically from the data, Saturday, and immediately the entire dashboard zooms into that specific. So you see only the Saturdays are now shown on the trend graph, all the averages and everything now shows only the Saturday. Of course, I can do other things here, by the way. In the dashboard itself, they baked as a panel also being able to filter by manufacturer, by category, zoom into specific quantity, how many bought 3 or more, and so on. So really comfortable to have a look. This is in a nutshell, and let's go back to the slides. Here we go. And let's go back. Okay, now let's talk about observability. That's the second use case. And observability front, you can use OpenSearch to detect, diagnose, and remediate issues that affect performance, scalability, availability, the things that you would like to do. Primarily, many people use that for log analytics. So they throw all their logs at the OpenSearch, store it there, and then start querying their logs, building dashboards. There are lots of tools around log analytics. There's the Discover pane, For those who know it from other systems, there's the dashboards that I'll show you in a bit. There are other tools such as Logtail, Log Surround, Log Patterns, and so on. You can query the data with Lucene for those who are native to Lucene, but there is also PPL, piped processing language, that makes it a bit easier to query the data and also query across other telemetry types like metrics and traces. And it integrates natively. We're here at the we all cloud-native community, so you see it integrates natively with cloud-native stack, like OpenTelemetry native protocol, all TLP is supported. The Jaeger trace data is supported, so you can use OpenSearch built-in capabilities as a backend for Jaeger trace data. You can use OpenSearch to visualize metrics data from Prometheus and others. So very natively, and again, let's just look at the demo. I think better than slideware is just have a look and see the thing itself. So I prepared a quick demo for you on observability as well. Let's switch to that relevant window. Where is that? Here we go. So that's for logs, and this time I started not with a dashboard. I'll show you also a dashboard. I start with the Discover pane, the Discover view. The Discover is just, many people, especially ones that, as I said, came from Solar, from Elasticsearch, from others, love this view to explore their logs, and this is the raw logs in this case. You just throw the logs at Elasticsearch, and then immediately it indexes, and then you see here, you can see all the relevant fields already typed. So you see this is a text, this is a timestamp, this is an IP, this is a numeric one, and so on. So geospatial coordinates, it's already typed, and you can now start and say, okay, I want to zoom in, I want to see this one, I want to add that also to the timetable, I want to see now, let's say I want to see the message body, so it adds this column. Now the message body is an interesting one in logs because, as you probably all know, logs are very verbose, and it's usually plain text. And it has a lot of useful information. If we look here, we see the date, we see the get, we see the URL for the operation, the 200 code, the Linux version, and so on and so forth. But in order to query on that data, we need to have full text indexing. And that's the power of OpenSearch. You don't need to now break it down. It will break it down for you, and you'll be able to query on any piece of that large body of message of the data. So this is plain text, and as I mentioned, you don't have to just work with that and write queries. You can also do dashboards. So moving on to the dashboards, you'll see a quick dashboard that we built for web traffic. This is web traffic log from the website, so you can see things such as how many unique visitors, the breakdown by the operating system, how many OS X, how many iOS, and so on. You see the trend over time for the different response codes. So 200 obviously is the big one, but you see the portion of 404s, the portion of 503s. You also see alerts during that. Here you see unique visitors versus average bytes overlaid on the same graph. Very powerful to correlate between the two file types that were downloaded on a scatter plot, how many zip, RPMs, GZ, and so on, or on a table format. Heat map, when were my site being hit the most, were the busy hours, and so on. Again, where do they come from around the globe in the map? You choose your design, your visualizations, whatever works for you. And again, you can filter. You can filter on the time window. You can filter on the different aspects. You can select a specific country that you want to focus on, and you'll see only the results for that specific country, a specific operating system, and so on. So really a powerful tool. Let's again switch back to the slides. Here we go. And back to the slides. So, how does that work in terms of the architecture? In essence, with the data prepper, you can ingest, enrich, transform your data collections so that they're suitable and optimized for analysis, and then you store it and index it inside Elasticsearch core. Then you use the PPL, pipe processing language, to query that data, and use the OpenSearch dashboards to visualize, to create your dashboards, to query with the discover, define alerts, and so on. That's really much in a nutshell. Now, I showed you OpenSearch dashboards, and that's an important word. This was one of the biggest areas of focus of development for the OpenSearch community. The sheer volume and complexity of observability data, or any data, also search data, is overwhelming, and in the OpenSearch project, we want to provide you with a powerful, easy to navigate tools to manage and visualize your data, to identify and respond to issues quickly, and to share insights within and across teams. The team collaboration is also a very important aspect, and it also has to be accessible and simple to manage permission controls. So this is what we aim at. For example, the screenshot here is from the anomaly detection that you can define on specific attributes, so that with the machine learning you can learn the trend on that specific attribute, and then it can flag anomalies. Lots of work around that. Ecosystem is another important area. Because every monitored system, wherever you run your systems, you have your own requirements, your own data sources, your own applications, your own storage, processing tool chain. And with OpenSearch, the beauty is that you can tailor your observability pipeline to suit your needs, your stack, your infrastructure, and your observability goals. So there are easy integrations with popular tools for collecting, managing, storing, visualizing information, such as the one you see here, including CNCF projects such as FluentBit, FluentD, OpenTelemetry, and others. Now, a word about AI and ML. Search essentially is evolving also in observability from lexical search into, which is based on keywords, into semantic search based on meaning and intent. And OpenSearch offers a full-fledged vector search, vector database for storing dense vectors, dense vector embeddings, and then running similarity search on them. You can see that there are quite a few algorithms that you can choose from to run these similarity checks. It supports multimodal search, meaning that you don't need to only search on text. You can also provide image, video, audio. It will know how to create embeddings and store them from that. And in addition to the dense vectors, it also supports the neural sparse vectors, sparse search. There's GPU acceleration for vector indexing, because vector indexing is a very heavy operation. And you can bring your own LLM, your own large language model, to create the embedding. So whichever you prefer, Claude, OpenAI, Bedrock, whatnot, you can bring your own. Let's talk about performance. Performance has been a point of emphasis for the OpenSearch community. A lot of users choose OpenSearch for its ability to ingest and store and query over massive amounts of data, but we all know that with huge data sets, performance is costly. It's costly both for the real-timeness of getting the answers quickly and do the root cause analysis, but also in terms of cost like storage, for storing the data, for indexing the data, and there is a lot of work on that. You can see some examples here that have been done. This is between version 1 and version 2. Performance improvements on indexing throughput, query latency, storage space reduction, all these dimensions, a lot of work. And I'll show you a bit more on that later. There's actually, 3 months ago, Trail of Bits released published results of their 4-month third-party performance study of OpenSearch and Elasticsearch. So very comprehensive study. They ran several benchmarks, the Big 5, Vector benchmark, and others. So if you're into performance, I encourage you to read the report. Very interesting to see. And now let's talk about the hot news that I have to share with you. OpenSearch 3.0, the next major release, is out. So let's give a round of applause for the project. Come on. That's really, really exciting to see. That's the first major release in 3 years, since 2022. And for good reasons. At OpenSearch, we follow semantic versioning, so we keep the breaking changes to the major releases, and to minimize the impact of breaking changes on the community and the users, we've kept 2.x as long as we could until 2.19, but now the community has realized it's time for the next major leap, and it is big. So let me show you why. V3 brings innovation on key priority areas. It starts with the infrastructure. So we've upgraded both Lucene and the JDK. Several folks here raised their hands, so you know what Lucene is. So now it's upgraded to Lucene version 10, the next major release. And also in terms of the JDK, it's now JDK 21 at minimum. So lots of benefits that come from that, even in the hardware level, like SIMD vectorization, more efficient posting, decoding, and more. Also, anything below Node.js 14 is now deprecated for the JavaScript 3.0 client. So all of these changes also make the project more future-proof, sustainable. You clean all the deprecated stuff. Beyond that, a lot of innovation. It's really a leap forward. I'll just give you a taste. It's much more than what you see on the screen, but just to give you a taste of the innovation, pool-based ingestion, for example, enables decoupling the source of the data. So now OpenSearch can pull from the telemetry sources. This also enables pulling data from streaming sources such as Kafka, Kinesis, Pulsar, Redpanda, and so on. And also the pool-based mechanism has its own back pressure mechanism that gives us more stable, resilient data pipelines. By the way, many thanks to the search platform team at Uber for their contributions to bringing this functionality to the project. I don't know if there's anyone from Uber here, but great work there. Also on the AI/ML front, AML workflows, there's native MCP, support for agentic AI. Everyone's been talking about agentic AI. This is the hot topic these days. So you have native model context protocol baked into OpenSearch. Also Visual Flow Builder for AI/ML workflows and others. Also continuous enhancement to performance. As I mentioned, this is a major theme for us with features such as the reader-writer separation, gRPC and protobuf support, GPU acceleration. Also in terms of understanding and observability into your own performance, there's the query builder, query insight, that you can actually see long-running heavy queries and start analyzing why they're heavy, why they're taking so long, and much more. Talking about performance, so continuing with version 3.0 release, you'll be seeing OpenSearch performance take another big leap. You see the stats here. The performance benchmarks that we've ran so far showed 20% on aggregate improvement across high-impact operations compared to the previous release, 2.19. And if you compare it to 1.3, then you get like amazing, like 9.5x faster across key query types. The GPU accelerated vector search that I mentioned brought like 9.3x faster index builds, 2 times higher throughput. You see the numbers, really exciting stuff. And here also deserves a shout out to the NVIDIA folks, team for NVIDIA for contributing to this feature. So amazing. And really in general, by the way, amazing to see the contribution for folks like NVIDIA, Uber, ByteDance, and others, also my folks at AWS, and others that contributed to this release and in general to the project. I think this is a true testament to the power of the community behind the project that makes this technology really stand out and carve out its differentiated space. So a big shout out to all the contributors in the community. And also a call out for you. If anyone here is involved, I already had an interesting chat before this talk with a fellow of the OpenSearch community. If you're also interested in the project and want to get involved, you can find us of course, on the GitHub repo, relevant, actually the 130-something repos. There's a very active Slack channel that you can join. We have forums, very active forums on the website, opensearch.org. We have a very active blog that you can read and get started. And we have events, as I mentioned already, OpenSearchCon, regional events around the world. We also have local user groups in many over, I think, 15 or more around the world. So we have in a few cities in the UK, across Germany, France. I would dearly love to see some user groups started, whether in Bratislava or in Prague or in any other cities in Czech and Slovak region. So if you are interested, happy to follow up on that as well. Scan this QR code. It has all the links in one QR code to make it easy for you. And of course, I'll be here throughout the day, so happy to take any follow-up conversations. Or if you're shy, you can find me, as I mentioned, at Horovits on Blue Sky, Mastodon, Twitter, LinkedIn, whatnot, Medium. So happy to reach out. And I think we should actually be having some time for questions. So Slido is your place to throw your questions. Happy to answer questions. And in the meantime, I'm Dotan Horovits, and thank you very much for listening.
Thank you very much, and we have questions. The first question, would you say that OpenTelemetry support in OpenSearch is production ready? Do you have any experience with this combination?
Yes, so OpenTelemetry is production ready, definitely so for traces. This has been the canonical way from the get-go, but also expanded to logs and now to metrics. I would say, so depending on your use case, if you're using it for tracing data, lots of experience that we have around there. Because this was the first one, then we added, as I mentioned, the logs and metrics. These are the less, but we still have experience. It's considered foolproof. You have OTLP endpoints within data prepper, so you can send it natively with OTLP. Or there is an exporter, an OpenTelemetry. In the OpenTelemetry collector, there are exporter components. So there's an OpenSearch exporter that you can use to send it directly to the cluster. Two ways. We're actually debating as a community, and there's an open RFC request for comments from the community of what would be the preferred path for the community on that. So if you are users of OpenTelemetry and OpenSearch, I'd love to hear your thoughts and maybe have you chime in on this community discussion as well. And whoever asked the question, I'll have a sticker for you for OpenSearch and maybe even a pair of socks for OpenSearch. So come after the talk.
Thank you very much. And the next question, we use Elasticsearch. How complicated would it be to switch to OpenSearch? Can OpenSearch use Elasticsearch database API or indices?
So, like anything in software architecture, the answer is it depends. It depends which version of Elasticsearch and what kind of usage you do with Elasticsearch. In general, however, I can say that the migration is pretty straightforward. As I mentioned, it started as a fork of Elasticsearch, so there's a lot of similarities. The API is very still compatible if you work on the API directly with the cluster. As you said on the UI, if you have dashboards and things like that on open source, OpenSearch, open source Kibana, for example, migrating them. So it really depends on what you use. If you use proprietary Elastic features that are XPack licensed and not open source, it'll be trickier. If you use the open source OpenSearch, it'd be simpler. And there are lots of guides on the internet. By the way, OpenSearch started as a fork of the last Apache 2.0 licensed Elasticsearch, which was 7.10. So if you use 7.10, the migration from 7.10 is pretty smoothless and transparent, seamless. The longer you proceed to the later versions, the more it will diverge because it's now two separate projects. So if you are considering the earlier, the better to make the migration. And lots of guides on the blog, and if you can't find it, happy to help with that as well.
Thank you. And our last question is authorization system in OpenSearch 3.0 has same features as in previous versions?
I think so. It's like previous versions. We had, like, as I said, 4 years, many previous versions. So I don't know which exactly authorization features there are. I suggest come to me, whoever asked the question, and I'm happy to discuss specifically what you use. But the idea was obviously just to expand and enhance. Usually we just deprecate things that are no longer, like with the security, for example, we did, with the move to JDK, we switched the security to the baked-in security within the JDK, the Java support, but in essence, we just expand, so it should be okay, but reach out to me, tell me what you use, and happy to follow up on that specifically.
Thank you very much. We don't have time for any more questions. Thank you for your very interesting presentation, and we continue in 5 minutes.
Thank you, everyone, for listening.